All right, here we are, the end of the tunnel for Unit 6. And in this case, we're just going to cover two more word type problems. But in this situation, these are probably the most applicable to real world events than most things that we've been doing in the past. So this is something that maybe you'll see down the road. Of course, you'll see it in other math classes, but maybe you'll actually see it in your professional job someday. Doesn't matter whether you're a tradesperson or whether you're working in the STEM fields. Math is math, and you find that you come across things like this all the time. Maybe you'll have the tools to solve it for you, but maybe you won't. So let's give you the mental tools to solve it. So here we go. Applications involving solving quadratic equations, day 2. So for this one, we're going to learn the last two of our four common types of quadratic word problems. In this case, we're going to talk about perimeter and area problems, which are similar to the ones that we saw in 6A, Unit 6A. But in those problems, we were always trying to find the maximum area or the maximum perimeter. In this case, that's not the situation. And then finally, we're going to talk about frame and border problems. That's a little fuzzy right now, but we'll clear it up once we get there. Now, because these are real-world applications, there's a very good chance that when we come up with a solution, some of that data is not going to be valid. So as it says here, we want to be sure to check the validity of our solution and reject any invalid solutions. So things like, maybe you'll get a negative measurement or a negative time or something along those lines. We want to make sure to get rid of those things because they're just not possible in most real-world situations. So let's get right to it. So first, we're going to start off with perimeter and area problems. So the perimeter problem, let's get right down here. Maybe we can fit both questions on one page here so we can see everything at once. Let's see. Okay, not quite, but close enough. So the width of a rectangle is 2 meters less than the length. Determine the dimensions of the rectangle that give an area of 48 meters squared. That doesn't really give us a lot to go on. All we know is that it's asking us to determine the length and the width, the dimensions of our rectangle. So since we don't know those, that makes sense to make those our unknown variables. So let's say let x be the width of the rectangle, and y be the length. Now you're welcome to use things like w and l. The only reason I use x and y is just because we're used to having those variables in all of our word problems up to this point. Just fix that. So I'm just trying to keep it a little bit more consistent with what you've seen in the past. Alrighty. So what do we know? We know the width of the rectangle, so x is the width, is 2 meters less than the length. What does that tell us? That tells us that x is equal to the y, the length, minus 2. Oh, great. Oh, hey, there's an equation. Awesome. What other equation can we come up with this? We need to say, then it says, determine the dimensions of the rectangle that gives an area of 48 meters squared. Well, this is a rectangle. We know how to calculate the area of a rectangle. So let's use that knowledge. So we know that the area right here, where'd it go? There it is. The area is 48 meters squared. So our equation number 2 could be the area, which is 48, is equal to, how do we calculate area? Length times width. So our width is x and our length is y. So we could just say x times y. Awesome. What have we been doing up to this point? How have we been solving these problems? This is the same problem we've seen in all of our previous questions. We have two equations. What do we do when we have two equations? We substitute. So in this case, I'm going to substitute equation 1 into equation 2. So that means we have 48 is equal to x which is y minus 2, y minus 2 times y. So let's expand. Now remember, our goal is to create a quadratic equation, which means we want 0 on one side of the equal sign. So we're going to bring that 48 over to the other side as well. So let's bring all this stuff together. So we're going to have 0 on the left, and on the right, we're going to have y times y squared. Y times y, which is going to give us y squared. Y times negative 2, so minus 2y. And then we have this 48, and we have to subtract it from both sides, so it means we're going to have minus 48. Okay, so now we have a quadratic equation. What are we going to do with that quadratic equation? Same thing we've been doing. We either have to choose to factor it so we can find the solutions, find the roots, find the x-intercepts, or we're going to have to use the quadratic formula. But these numbers seem pretty reasonable, so let's see if we can factor this. So that means we need two numbers that add to 2 and multiply to 48. So 1 and 48, no. 2 and 24, no. 3 and 16, no. 4 and 12, no. 5 doesn't go. 6 and 8, oh, 6 and 8 go. Yes, we can do that. So if we have 6 and 8, this tells me that they're different, and this one tells me the bigger one is the negative. So that means we have 6 and negative 8. All right, so we have our equation. So y is equal to y plus 6 and y minus 8. Now we need to solve. So for each one of these, we have y plus 6 is equal to 0, which means y is equal to negative 6. And then over here, we have y minus 8 is equal to 0, which means y is equal to 8. Now, what does y represent? Y represents the length. Oh. So if that's the situation, that means that this y is equal to minus 6 is actually impossible, because that would give us a length of negative 6. And that's impossible in every situation. So we are going to reject this one, which means y is equal to 8 is a solution that we're going to keep. So now that we have our length, we need to calculate our width. So we're going to have to substitute this back into one of our two equations to solve for our width. So obviously the easiest one would be equation number 1. So let's sub y is equal to 8 back into equation 1. So we have x is equal to y, which is 8, minus 2. So x is equal to 6. So now we know our width is 6 and our length is 8. So therefore, the dimensions of the rectangle are 6 meters and 8 meters. Now, some of you might be saying, well, wait, don't we have to say like 6 meters wide and 8 meters long? We could. We absolutely could. But you have to remember that rectangles are just rectangles, and we arbitrarily decide which side is length and which side is width. We could reverse those, and it's still the same rectangle. So it doesn't really make a difference as long as we know the dimensions of the two sides. Okay, so if we do 6 times 8 or 8 times 6, it's still going to give us 48. So it still works out. All right, let's go down to the next one. So in the next one here, we're still dealing with a rectangle. I don't want to go too far here. Let's pop, right there. All right. So the length and width of a rectangle are 6 meters and 4 meters. Oh, they're telling us the length and width of the rectangle this time. So let's go draw a picture. All right. So we have a rectangle like this. So the length and width. So that gives us a length of 6 and a width of 4. Great. Does that help us? I don't know. Let's read the rest of the question. So the length and width of the rectangle are 6 meters and 4 meters. When each dimension is increased by the same amount, the area of the new rectangle is 50 meters squared. So that means that the length is going to get a little bit longer, but it also means the width is going to get a little bit longer. So what's going to happen is we're going to create a new rectangle that looks like this. Now, the thing is, it says that each dimension is increased by the same amount. Now, the question is, find the dimensions of the new rectangle rounded to the nearest tenth. We can't find those newest dimensions until we understand something. We need to know how much it was increased by. So that is our unknown value. I know we're trying to calculate the new dimensions, but those new dimensions require that unknown value. So really our unknown value is that amount of increase. So we're going to say let x be the increase made to the dimensions. We only need one variable because they both increase by the same amount. Let x be the increase made to the dimensions. Now, from our picture's perspective, that means that this distance right here is x, and this distance right here is also x. We know that the area of the new rectangle, the whole rectangle, is going to be 50. So the whole area is equal to 50 meters squared. Well, that's great, but what does that tell us? Well, we have to look at the whole picture here. What is the actual distance? How do I calculate that 50? That means I need this whole length over here. Well, what is that length? That length is 6 plus x. Whereas the width over here is 4 plus x. I don't think I can write this upside down, but we're going to try. 4 plus, that's not bad. All right, so that means the length and width, we have measurements for the whole thing. That means we can create an equation. So we know that the whole thing is equal to 50. And you know what, let's go the other way, just to keep this simple. There we go. So our length is 6 plus x. Our width is 4 plus x. And that whole thing comes together to be exactly 50. That looks to be about all the information I need. And you're like, hey, that looks like we've already solved the problem. Those look like two factors right now. Now that would be true if this were a 0, but it's not. So we have to actually do the work here. So we're going to start by foiling and expanding our two brackets. So 6 times 4, that's 24. 6 times x, that's 6x. And then x times 4 is 4x. And then x times x is x squared. Now we need to bring this 50 over to the other side so we can have 0 on the right. So we're going to say subtract 50 equals 0. Now we got to bring everything together. So there's only one x squared, so we'll leave that one all on its lonesome. Then we have 6 plus 4x, so that's 10x. And then we have 24 minus 50, so that's minus 26 equals 0. Now we have a quadratic equation which we can solve. Now, we can try and factor it. That seems like a reasonable thing to do. Let's see if we can come up with some factors. So that means that we need to find two numbers that, we're running out of space here. Let's say two numbers that add to 10 and multiply to 26. So 1 and 26, nope. 2 and 13, nope. 3 doesn't, no, 3 doesn't work. 4, nope. We don't really have a lot of options here. There's nothing that works here. There's no solution. So what this tells me is that it's not factorable. Okay. So that means we need to find another way. So if we can't factor it, that means that we need to use the quadratic formula. That's just the way it is. So what is our A, B, and our C? Our A is going to be 1. Our B is 10. And our C is minus 26. Those are some big numbers to work with, but they are what they are. So let's go calculate. So let's do x is equal to negative b, so negative 10, plus or minus the square root of b squared, so 10 squared, minus 4 times a, which is 1, times c, which is 26. And that whole thing is under the square root, and this entire thing is over top of 2 times a, which is 1. Okay, well, it's time to actually do the math now. So we have x is equal to negative 10, leave that alone, plus or minus, leave that alone, the square root. So 10 squared, that's 100. Now we have minus 4 times, oh, this should be negative 26. 4 times negative 26, that's important, because otherwise we wouldn't actually work, which is 104. So it's going to be 4 plus 104. And then that's all over 2. So just to simplify this a little bit further, we have x is equal to negative 10 plus or minus the square root of 204, which is definitely not a nice number. And that's going to be all over 2. So that means we got to do the actual separation. We have to do both calculations. The plus square root of 204 and the minus square root of 204. So let's go this direction. You will be my plus, and this direction you will be my minus. So when I do this and I have negative 10 plus the square root of 204 divided by 2, what we end up with is x is equal to approximately, again, this is just a calculator thing, 2.1. Approximately. Over here, we end up with x is approximately equal to negative 12.1. So we got to look at these numbers and what makes sense. If x is 2.1, that's saying that's the increase, okay? So if x is 2.1, our numbers get bigger. That makes sense. But if x is negative 12.1, that would give us a negative dimension for our length and our width. So that doesn't actually work. So we have to reject this. So we are going to accept this, and we are going to reject this one. Reject produces impossible dimensions. There we go. So we know our increases, but the question was to find the actual dimensions. So that means we actually have to calculate each one. Well, that's okay. We have equations for both of those. So the length, we don't have L's or W's or anything like that or X's. We're just saying the length. So the length is just going to be equal to 6 plus X. What is X? X is 2.1. I spelt length very, very wrong. That was pretty impressive. Let's try this again. There we go. Length is equal to 6 plus 2.1, which is going to be, now we want to say approximately because that 2.1 is approximately as well. So that means our length is approximately equal to 8.1. And make that circle a little bit bigger. And that means our width is going to be similar. It's going to be equal to, in this case, it is 4 plus 1. 4 plus 2.1. And we end up with 6.1. Approximately. So we've got all of our dimensions. Now it's just a matter of giving a final concluding statement. Remember the approximate, okay? So therefore, the new dimensions are approximately 6.1 meters and 8.1 meters. There we go. So that gives us a fairly straightforward example of doing these types of problems. We're going to do one more because you just need a lot of practice with these things because the shapes are not always the same. So we're going to do one with a different shape this time. So if we scroll down to the next page, let's do a triangle. This should be a little bit more of an interesting experience for us. So in this case, this one says the height of a triangle is 8 centimeters longer than its base. Now we don't know the type of triangle it is, and it doesn't really matter. Because if we keep reading the question, it says if the area of the triangle is 64 centimeters squared, find the base and the height. So we're trying to find the base and the height. We're given the area, and we're given the fact that the height of the triangle is 8 centimeters longer. Now, the reason why it doesn't matter what shape of triangle it is because area of a triangle is calculated the same no matter what. We know that the area of a triangle is equal to 1/2 times base times height. Great. So what does that tell us? It tells us that we need more information. We need to know the base and the height. Do we know them? No, not really. So let's start off with some let statements. So first of all, let's say let x be the base of the triangle. And y will be the height. The height of the triangle. There we go. So if that's the case here, we know that we could rewrite this as area is equal to 1/2 x, x times y, right? But that doesn't allow us to solve it anymore. We do know that area is actually 64, so we could rewrite that as well. But that's still not enough. So we can put 64 here because we still have two variables. But luckily, we were given a little bit of information. We were told that the height of the triangle is 8 centimeters longer than the base. That tells me that y is equal to the base plus 8. There's our equation number 1. Now, if our equation number 2 is what we've been working on over here, 64 is equal to 1/2 xy, we can now substitute. So let's do that. So let's say, how do I want to do this? Let's substitute 1 into 2. Yeah. I was just debating where to do that. We're going to do that over here, just so we have a little bit of space here. So that means our equation is 64, which is equal to 1/2 times x plus 8. Oops. Come on, erase. Doesn't want to erase. It's starting to get laggy like it used to. Might have to change some things up soon. That's okay. X plus 8. Now, your immediate choice right now would probably be, oh, I want to distribute that x through there. And that would be a fine choice, except we still have this half sitting out here. So how are we going to get rid of this half? Well, in order to get rid of this half, I need to multiply both sides by 2, because I'm dividing by 2 right now, right? So I'm going to multiply both sides by 2. And what I'm going to end up with is, so we're going to say 64 times 2. That's going to give us a 128. Oops, 128. That was not what I wanted to write. That's going to give us 128. On the right-hand side, the half is gone. So now we just have x times x plus 8. So let's bring everything together. We're going to bring the 128 over to the right-hand side. We're going to distribute the x through the brackets, and we're going to end up with a quadratic equation. So 0 is equal to x times x, which is x squared, x times 8, which is 8x. And then we're going to subtract from that 128. We now have our quadratic equation. Yay! So we have to look and decide, well, do we need to use the quadratic formula, or can we actually factor this thing? Let's find out. So we need to add to 8 and multiply to 128. Now, after some time, what you're going to end up with is you're going to find two numbers that do actually work. We're going to find 8 and 16. Now we can see that this negative tells me that they're going to be different signs, and this positive tells me that the biggest number is positive. That means the 8 is negative. So now what we have is, we have 0 is equal to x plus 16 and x minus 8. Now we do what we've always done. We're going to set each one of these equal to 0. X plus 16 is equal to 0. That means x is equal to negative 16. And on the right-hand side here, we have x minus 8 is equal to 0, which means x is equal to 8. Now, what does x represent in our question here? It represents the base of the triangle. That means immediately this x is equal to negative 16 has to be rejected, because it's telling us the base of our triangle is negative 16, which doesn't make any sense at all. Okay? So that means that our actual base is equal to 8. Okay, so now that we know our base, we need to find our height. Well, over here, equation number 1 is the calculation for our height. So we're going to sub x is equal to 8 into equation 1. Alrighty, so that means that we have y is equal to 8 plus 8. So y is equal to 16. Well, there's our dimensions then. We've found everything we need, so therefore, the base of the triangle is 8 meters. Is it meters? Centimeters. 8 centimeters. And the height, see, this time it actually matters which is which, right? It's not a rectangle anymore. Is 16 centimeters. And that whole thing will yield a area of 64 centimeters squared. Awesome. So that's the end of those perimeter and area problems. Let's branch out a little bit further. Let's get into something more interesting in my perspective, the frame and border problems. Now, you're going to see a lot of questions like this on tests, practice work, assignments, the exam, and things like that, and they're all going to be basically structured the same. You're going to have some shape which has certain dimensions, and then that shape is either going to grow or shrink, and it's going to create either an increased area, volume, or something along those lines, or a decreased area or volume. And your job is almost always going to be to figure out what the dimensions of the new shape are, or how much it increased or decreased by. And that's pretty much the perspective in every question. So let's try this out. So imagine this one. So a big key point here is in these questions, I really highly recommend that you draw a picture if you can. So a picture, so think of it like a picture frame. A picture that is measured by 10 centimeters by 5 centimeters is framed with a uniform border. Uniform means the same size. Okay, so a uniform border. So it originally started at a size like this. Let's say 10 centimeters and 5 centimeters. Actually, let me draw that inside. There we go. This is going to be 10 centimeters and this is going to be 5 centimeters. Awesome. But it says here that it is framed by a border, a uniform border, which means it's the exact same width the entire way around. So this width is the same as this width, which is the same as this width, which is the same as this width. They're all the same. That's good to know. Okay, so a picture that is measured 10 centimeters by 5 centimeters is framed by a uniform border that is the same width on all sides of the picture. The area of the border, just the border, is twice the area of the picture. Determine the width of the border. So in this case, what is unknown? The stuff that's unknown is the actual border width itself. So we're going to let X be the uniform width of the border. It's a uniform border width. So if I'm drawing that in my picture, that means this is X, this is X, this is X, and this is X. Okay. What other information does it tell us? It tells us that, where is it? The area of the border itself, so just the area of the border, let's say area of border, is twice the area of the picture. The picture itself, which is just inside of here. So what is the area of the picture? So this is equal to 2 times the area of the picture. Well, what's the area of the picture? The picture is the space inside, just the picture itself. So that's just 5 times 10, which is equal to 50. So that means that the area of the border is equal to 2 times 50. So the area of the border is equal to 100 centimeters squared. Okay. So we know the area of the border. That's great. But it's asking us to determine the width of the border. How can we figure that out? We need more information, or we need to come up with more ways to kind of calculate this in from another viewpoint. So looking at this whole thing, the whole picture itself, can we calculate anything else? Can we calculate, say, for example, can we calculate the area of the border in another way? Think about it like this. The area of the border is the equivalent of the area of the whole rectangle minus just the area of the picture. So basically we're finding whatever's left over, and that's the area of the border. So that's another way we could approach this. But what is that? So we know that the area of the border is 100. We also know that the area of the border can be calculated by taking the area of the whole picture. So let's give that another way. Let's say, let's just call that one area. So area of the whole thing. And if we take that, the full rectangle, and subtract from that just the area of the picture, that will give us the area of the border. Do we know any of these values? Well, we know the area of the border, so we can substitute that 100 in there. We actually know the area of the picture too. The area of the picture is only 50. But what's the area of the whole rectangle? Well, the area is calculated. We know how to calculate that. Length times width. So if this is my length and this is my width, what is that? Well, we know that this whole piece is 10. But then it has to go x on both directions. So it's actually going to be 10 plus 2x. Similarly speaking, for the width, this is 5, but then it has to go a distance of x on both sides. So this one's going to be 5 plus 2x. So now we have a length and a width. So we can actually substitute that in there. So the area of the full picture is our length, which is 10 plus 2x, multiplied by our width, which is 5 plus 2x. And then we just have our little minus 50 over here on the side. Oh, now we get to a point where we can actually solve stuff. So what we need to do is first expand and simplify and turn this thing into a quadratic equation. So let's multiply things through. We're going to bring that 100 over to the other side, of course, because we know we're making a quadratic. So quadratic equation. So that 0 is going to be there. Now let's do the work inside. So we have 10 times 5, so that's going to give us 50. We have 10 times 2x, so that's going to give us 20x. Now we have 2x times 5, that's going to give us 10x. And then we have 2x times 2x, that's going to give us 4x squared. Now we have our minus 50, and we have our minus 100 from the other side. Let's bring this all together. So 0 is equal to, we got 4x squared. We've got 30x. And now we have 50 minus 50 minus 100. So that's going to end up with a value of minus 100. Okay. Now, can we factor this thing? Well, we could divide out a 2. Then we have 2x squared plus 15x minus 50. But I can tell you right now, after some trial and error, I was not able to come up with factors for either the complex factoring, and I couldn't get it down to simple trinomial. So that means this is unfactorable. Well, if it's not factorable, what choice do we have? We only have one choice, the quadratic formula. Oh, okay. So what are our numbers? Let's look at this. We have A is equal to 4. We have B is equal to 30. And we have C is equal to negative 100. These are some monster numbers, but that doesn't change our work in any way, shape, or form. So what are we calculating? We're saying x is going to be equal to what? X is going to be equal to negative b, negative 30, plus or minus the square root of b squared, so 30 squared, minus 4 times a is 4, times c, which is negative 100. And that whole thing, oh, that should not be 30 cubed. Why does that say cubed? I don't think that I would have done that, but apparently I did. Get rid of that. That should be 30 squared. There we go. That whole thing is square rooted, and this whole thing is 2 times a, which is 4. Okay, let's simplify this the best we can. X is equal to negative 30 plus or minus the square root of. So 30 squared is 900. I know it's a big number. And then we have 100 times 4, which is going to give us 400, times 4, which is going to give us 1600. So we have two negatives there, so that gives us a positive. So plus 1600. Whew, it's a big number here. And then underneath we have an 8. Let's keep simplifying as much as we can. X is equal to negative 30 plus or minus the square root of 900 plus 1600 is 2500. That sounds promising. Maybe we'll get a good number. And that's all over 8. Now, if you do the square root of 2500, you're actually going to find that that's exactly 50. Oh, that's great news. So now we have x is equal to negative 30 plus or minus 50 all over 8. So now we have two possibilities. We have the positive possibility, and that's going to be x is equal to negative 30 plus 50 over 8, which is going to give us negative 30 plus 50. That's 20 divided by 8. That's going to give you 2.5 centimeters, 2.5. And then the minus root, we have x is equal to negative 30 minus 50 over 8. And that's actually going to give us a nice round number, but the problem is it's negative. So since it's negative and we're talking about a dimension here, we're talking about a uniform border width, it can't have a dimension of negative 10. All right? If this were the previous questions with the numbers and whatnot, that would work fine. But in this case, it does not work. So we have to reject this. Cannot have a negative dimension. Okay? So that means that 2.5 is the actual width that we're looking for. And we're done. We just need a therefore statement. Therefore, the border width is 2.5 centimeters. So all these questions are going to be basically the same. We got to figure out an equation. A lot of times you're just going to be writing out all the information you can think of when we're talking about these questions and figuring out what equations will actually help you. You're going to have to go back through your knowledge and try and remember your old equations sometimes on these questions because they may be a little bit thinking oriented. But that's part of the package, unfortunately. We got to be able to do everything. All right, we're going to try this one more time and then we're going to call it a day. This video is already getting long. Okay. So we have a photograph that was originally 15 centimeters by 10 centimeters. Okay, so let's draw that photograph. So that photograph was, let's say we draw it like this. All right, so let's say it was 15 centimeters in this dimension and 10 centimeters in this dimension. Okay, so height of 15 and a width, or length of 15 and a width of 10. So is cropped. Cropped means cut smaller, okay? When you crop an image, you're cutting parts off. So is cropped by removing the same width from the top and left side. So that means we're cutting off the same amount from the top and from the left. How much is that? I don't know. Cropping reduces the area, so the new area is 46 centimeters squared. So the area inside of here equals 46 centimeters. That may or may not help us. What are the dimensions of the cropped photograph? So if the original is 10 by 15, what is the dimensions on the inside? So just like we did last time, we're going to let x be the change in the dimension. So last time it was the increase. So in this case, this is the decrease. So we're going to say let x be the cropped, the width cropped from the top left. From the top left. Okay. Now with that in mind, that means that this is x and so is this. So just like we did last time, we can determine our new dimensions relative to x in the original size. So if this original width was 10, that means this new width is 10 minus this side from the left. So this new dimension is 10 minus x. So what is the dimension on the length here? It's the same idea. It's 15, the full dimension, minus that little piece from the top. So this one is going to be 15 minus x, and this just goes up from here down to here. Okay, so we have our new width and we have our new height, and that actually tells us what our new area is too. Oh, that sounds like we got quite a bit of information, pretty much everything we need. So let's put that into an equation and see what we get. So we know that 10 minus x multiplied by 15 minus x is going to give us a new area of 46. Hopefully that'll give us everything we need. Remember our goal. Our goal is to figure out the dimensions, the length and the width of the new picture. We're not trying to figure out x this time. In fact, we don't care about x. Maybe it'll help us, maybe it won't. It should because it's our unknown value. But let's get to it. So we have 10 times 15. That's going to give us 150. Oops, what's going on here? Whoa. Control Z. I don't know what just happened here. There we go. My whole computer just went screwy on me. There we go. I think I'm lagging out. All right, anyways. Let me draw. So, there we go. 150. So 10 times 15 is 150. 10 times negative x gives us negative 10x. Negative x times 15 gives us negative 15x. Negative x times negative x gives us positive x squared. And then we got to bring our 46 over to the other side. So minus 46. And that whole thing is going to be equal to 0. So let's collect and simplify. So we have our x squared. And then we have minus 10 minus 15. So that's minus 25x. And then we have 150 minus 46. So that's going to be 104. 104? Yes. Yeah. Equals 0. So this is where we're at. Can we factor this thing? Are there any two numbers that add to 25 and multiply to 20 and multiply to 104? Unfortunately, there are not. So this is unfactorable. Now you're probably thinking, well, how do you know? Well, I took the time and I went with a calculator and I went over all of the multiples to get up to 104, and none of them would add up to 25. So unfortunately, we can't really do anything with this. So that means we have to use the quadratic formula. So let's figure out what our A, B, and C are. Our A is just a 1. Our B is a negative 25. And our C is 104. So we got big numbers again this time. But that's the nature of the beast. So let's plug everything in. So that means we have x is equal to negative 25. So minus negative 25. So we know what that is, but I'll write it out. Oh my goodness. I'm doing so many edits here that the computer is getting super laggy on me here. X is equal to negative 25. All right, plus or minus the square root of b squared, so negative 25 squared. Okay, oh my goodness, that looks terrible too. Not a fan of drawing on these tablets. Here we go. Negative 25 squared minus 4 times A is 1, times C, which is 104. Such a big number. And that whole thing is square rooted, and this whole thing is 2 times A, which is 1. Let's simplify as much as we possibly can. So x is equal to 25 plus or minus the square root. 25 squared is going to give you 625. Now we have 4 times 1 times 104. So that's going to give us 416, and it's minus because we only have one negative there. So minus 416. And that's all over 2. We keep simplifying, so we have x is equal to 25 plus or minus the square root of 625 minus 416, which is going to give us 209. All over 2. Now, unfortunately, these numbers are not nice. They don't work out nicely, so we just have to do the math, plug it into your calculator, and when you do plus the square root of 209, you end up with x is approximately equal to 19.7. And then when you do the minus the square root of 209, you end up with x is approximately equal to 5.3. They're both positive. So are they both valid? Is that possible? Well, we have to look at the question. The question is, x represents the amount of width cropped. If our width starts at 15 and 10, and we subtract 19.7 from either of those, we're going to end up with bad dimensions in both cases. So we have to reject. Reject. Too big. So that means x is approximately equal to 5.3 is the number we're looking for. So there we go. So now we know our width, our crop width, but that doesn't actually tell us the dimensions of the new picture. We have to do that. We have to do the calculations. So we can see that our width is equal to 10 minus x, which is 10 minus, now that we've substituted the x, minus approximately 5.3. And what you're going to end up with is the width is approximately equal to 4.7, approximately. And length is going to be similar. Length is equal to 15 minus x. When we substitute that in, it becomes approximate. We have 15 minus 5.3. And we get the length that's approximately equal to 9.7. Well, there's our dimensions. Therefore, the dimensions of the cropped photo are 4.7 centimeters and 9.7 centimeters. Alrighty, that is it. That one took a little bit longer because the questions are a little bit more detailed and there's more steps involved, but it still breaks down to the same math of solving a quadratic equation every single time, either through factoring or through the quadratic formula. Okay, so once you've got those equations set up, which is the most tricky part, just plug it into the math you already know and you're good to go. That's it for this unit. You have tons of review materials and practice materials to go through, so start going through those once you finish the homework and get prepped for your tests. Good luck.